look at the function carefully, you have the elements of the first column are xyz, second column are x square, y square, z square, and third column the elements are sum of two elements, that is 1 plus px cube, 1 plus py cube, 1 plus pz cube. So first of all you take left hand side, in this case you take left hand side as x, y, z, x square, y square, z square, 1 plus px cube, 1 plus py cube, 1 plus pz cube. Now first of all, we should rewrite it as sum of two determinants. Column 1 and column 2 will keep as such, and by using the property of determinant, the column 3, the elements of the column 3 being sum of two elements, so we can separately write it as sum of two determinants, like this. See, the first determinant will be x, y, z, x cube, x square, y square, z square, and from the third column we will take only 1, 1, 1, and plus the second determinant keeping the first two columns as such, x, y, z, x square, y square, z square, and the third column will be the rest of it, that is px cube, py cube, and pz cube. This is the using the property of determinant, that if any row or column is expressed as sum of two elements, then we can express it as sum of two determinants, separating the one which is expressed as sum of two elements and keeping the other two rows or column the same. Now, you know, in the first determinant, you interchange the things, interchange C2 and C3, C2 and C3, and then you change C1 and C2. So you will get minus and minus plus, because you are making two changes, so it will be minus and minus plus. You know, because if you interchange any two rows or columns, the value of determinant changes the sign. And because here we are making two changes, two interchanges, so it will become minus and minus plus. So in the first column, that way you will get 1, 1, 1. In the second column you will get x, y, z. In the third column you get x square, y square, and z square, and plus. What about the second, determinant? You take first of all p common from column 3. So you get plus p times x, x square, x cube, y, y square, y cube, z, z square, z cube. And now from second, keep the first determinant as such, and from the second determinant, take x, y, z common from row 1, row 2, and row 3 respectively. You know, at a time we can take a number common from any one row or column. So if you are taking common from row 1, row 2, and row 3, outside we have the product x, y, z. P is already there. So it will be p times x, y, z. So you get, still keep the first determinant 1, 1, 1, x, y, z, x square, y square, z square as such. And from the second you are taking x, y, z common from row 1, 2, 3 respectively. So outside you get p, x, y, z, and you left with in column 1, that way you will get 1, 1, 1. In column 2 you will get x, y, z, and column 3 you will left with x square, y square, z square. And now do you find that this determinant, the first determinant, and from the second we can take the determinant common, and you will get 1 plus p x, y, z outside. So now taking the determinant itself, that is 1, 1, 1, x, y, z, x square, y square, z square common, so you left with 1 plus p times xyz outside, and the determinant 1, 1, 1, xyz, x square, y square, z square. And now if you look at the right hand side, of course we need this factor common, that is 1 plus p times xyz, and what else you need? You need x minus y, y minus z, z minus x, which is now a routine kind of determinant question, because in column 1 you have 1, 1, 1, so you have the set procedure that you replace R2 by R2 minus R1 and R3 by R3 minus R1 to get 2 zeros in column 1. So you get, of course, 1 plus p x y z is common, keeping the row 1 as such, that is 1 x square, and now R2 minus R1 will make it 0, y minus x, y square minus x square, and R3 minus R1 will give you 0, z minus x, z square minus x square. And now clearly we can take y minus x common from R2 and z minus x common from R3. So you get 1 plus p x y z, this factor is already common, then you have y minus x and z minus x factors common. So now you left with still the first row as such, and from the second row you have taken y minus x common, so you get 0, 1, and the factors of y square minus x square are y minus x, y plus x. Y minus x you have taken common, so you left with y plus x. And similarly in the third row, you will get 0, 1, and z square minus x square have two factors, z minus x, z plus x. Z minus x you have taken common, so you left with z plus x. And now, of course, this is the time we can expand it along column 1. So expand, because in column 1 you have 2 zeros. Expand the determinant along column 1. So outside the factors 1 plus p x y z, y minus x, and z minus x is already there. When you expand the bracket, when you expand the determinant, you get 1 time 1 into z plus x, that is z plus x, and minus 1 into y plus x, so it will be y plus x. So you get this. And now you get 1 plus p x y z, this factor as such. From factor y minus x, you take a minus common to make it x minus y, keeping z minus x as such. And when you open the bracket, the last factor, actually you get z minus y, so you take minus common to make it y minus z. And now the minus and minus sign cancels, so you get 1 plus p x y z factor is already there, and from rest of the factors you have x minus y, y minus z, and into z minus x, which is the required right hand side. And there is